Hey guys, this is Mr. Kung speaking. I'm going to show you all about reflection of light. So first of all, there's a few laws of light. Like whenever you turn on a light, you don't notice this, but we can think about light as multiple rays coming from the source. Light always travels in a straight line. So for example, if I have a point A, like over here, point A, and I have a point B over here, it will not travel like this. It won't do that. It will not go like this. It will not go like that. It will travel in a straight line. So basically, anytime you have light in a ray diagram, you always draw it traveling in a straight line. So if this is A and that's B, you'll see this. Okay, granted that's not a perfectly straight line, but I haven't got a ruler for the screen, so I'm just going to stick with that. All right, so now let me just write down that rule. Light always travels in a straight line. Okay, so now let's talk about reflection. In any of our ray diagrams, these are diagrams that show the rays of light, I'm going to show light traveling in a straight line with an arrow to show you which direction it's moving. So if this light is going from A to B, then I'm going to draw an arrowhead showing that it moved from A to B. So I'm going to start with plane mirrors. Plane mirrors are the mirrors that you have on your wall in your bathroom. These are flat mirrors. We see them a lot everywhere. So to draw a plane mirror, I'm just going to draw a line, and just to show that nothing goes behind that mirror, I'm just going to kind of shade behind it. Nothing goes here. So no light passes through the mirror to the other side. So that means if I have a straight line coming from some light source over here, so like a light bulb, and light is coming from that light bulb, it's going to hit the mirror and reflect off of it. It's not going to go through. Okay, so this is showing now light striking the mirror from that light source and then bouncing off that mirror and coming back. Okay, so now we're going to explore what happens to light when it hits a plane mirror. So more specifically, let's take a look at exactly what angle the light bounces back at. So there's something called the law of reflection. And to understand that law, let's take a look at an example here. Whenever you have a light ray strike a mirror at a certain angle, it's going to bounce back out at a certain angle. Let's take a look at what I mean by the angles. So in order to show the angles, I need to draw what's called a normal line. A normal line is 90 degrees to the surface that the light struck. So this is the surface that the light hit, and you can see where the light hits right there. I'm going to draw a 90-degree line, perpendicular line, from that flat surface. So here, this angle is 90 degrees. And this is called a normal line. So we're going to talk a lot about normal lines, but anytime you have reflection or even refraction, you need to figure out where that normal line is. And a normal line is always 90 degrees from the surface that the light touched. So now that we have a normal line, we will see that this angle here from the normal line to the ray which struck the mirror, this angle is called I, the angle of incidence. And so this ray is called the incident ray. Okay, incidence just means, the word incident means kind of the source or where it comes from. So this is where the light came from. It came from the source, and it's like kind of the initial light ray that hit the mirror. So the law of reflection states that this angle of incidence should equal the angle of reflection. And here, this angle here, R, is the angle of reflection. And of course, you can guess what this ray is called. The ray that comes off of the mirror after the light hit it, this is called the reflected ray. So you can see we've got some terms here now. We've got the incident ray striking the plane mirror, the flat mirror, and bouncing off, and then we've got a reflected ray. We've got an angle of incidence. The angle of incidence right here is basically the angle from the normal line to the incident ray. The angle of reflection right here, which goes from the normal line to the reflected ray. These two angles, according to the law of reflection, these two angles are always equal to each other. Okay, so let me write down the law of reflection, and then we can see some more examples of this. So here's the law of reflection. The law of reflection states that the angle of incidence is always equal to the angle of reflection. So in other words, if you have a plane mirror like this, let me draw it on this side because it works both ways, right? It works anywhere the plane mirror is. If you have a plane mirror like this, if I've got an incident ray that strikes the mirror head on like this, well, the angle of incidence is actually 0. Because if you drew a normal line at this point, this light ray would be right on that normal line. So there's actually no angle. So that light ray would be expected to bounce right back at the source like this. If you had an incident ray that is at a very sharp angle, like say like this, a very large angle from the normal line, then you would expect it to bounce off like this. If you had a light ray that came in at an angle like this, then you would expect it to come back like that. And that is because the law states that the angle of incidence should be equal to the angle of reflection. Just like in this case, these two angles are equal. Okay? So that is expected not just for light, but if you play any type of sport that involves hitting something against a wall, like squash or even hockey, when you take a shot and it hits the boards and comes back, reflects off the boards, you would expect this law to apply to that as well. Or if you play pool and you're playing the angles, this is very important for all those types of sports. Because if you come in at a certain angle, like say from here, you would expect it to bounce off either to somebody you're passing to at this angle. Okay, and if you throw a ball right straight at the wall, you expect it to come straight back at you if you threw it at a 90-degree angle to the wall. Okay, let's take a look at some more examples then. So let me draw another plane mirror, and I'm going to move this plane mirror around just so you don't get too used to, okay, a plane mirror is always on the left side or the right side. Let's just draw a plane mirror up here. So now, let's say my light ray is coming from a light source over here, and it's shining and hitting this plane mirror. How do we figure out what the reflected ray is going to look like? Now, at this point, you can take a piece of paper and see if you can estimate where that light ray is going to end up. Where's the reflected ray going to be? So based on what we talked about, you should always draw a normal line. So a normal line is at a 90-degree angle to where that light just touched the mirror. It touched right here. So we're going to draw a normal line, a 90-degree perpendicular line to that flat surface. Now, the incident ray is about this big. The incident angle of incidence, is about that big. So we would expect, following the law of reflection, that the reflected angle of reflection should be the same size. So just by estimation, you can use a protractor and actually measure it, but we won't do that here. We just want to get the idea first. So these two angles should be equal to each other. So knowing that, I think the reflected ray, I would put it around there. Okay? So if you estimated that correctly, congratulations. Let's try another example. See if you can get this one. All right. So let me, again, vary where I put our plane mirror. Let's put it over here. Okay, so now I'm going to fire a light ray at this plane mirror like this. A good way to figure out where to put the normal line is actually, quite often, if I'm actually drawing this accurately, I would take a piece of paper or even like a Post-it note, and I would line it up with the plane mirror to get my 90-degree angle. Of course, you can just estimate it, but sometimes it's nice to kind of get it exactly. So something like a Post-it note, you can, let me just move this around. You can rotate it and put it flat against your plane mirror like this. Then your normal line would be right here. Okay, and then you've got kind of an exact 90-degree angle here. So now we can see that the angle of incidence looks like this. Our angle of reflection should be the same size. So that means our reflected ray coming off of that point, I'm not doing this super accurately because I'm kind of wobbly with my pen here, my stylus, but it should be around there. Okay? All right, so that's it for plane mirrors. Our next video is going to be about convex mirrors and concave mirrors.